Imagine there's a party happening right now, a cosmic party, and you're not even aware of it. Yes, a grand universal soiree teeming with unseen guests, dancing to the silent symphony of the cosmos. These invisible attendees, my friends, are what scientists call dark matter. Now, you might wonder, what is dark matter? Well, it's a bit like the quiet wallflower at the party, mostly going unnoticed, but having a profound impact on the overall event. In the cosmic scale, dark matter is the unseen component of the universe, accounting for the majority of its mass. Yes, you heard right, the majority of the universe's mass. To put it simply, about 85% of the matter in the universe is dark matter. But here's where things get a bit tricky. Despite its overwhelming presence, we can't see, touch, or interact directly with dark matter. It's like trying to catch smoke with your bare hands. So how do we even know it's there? Well, it's all about the gravitational pull. You see, just like the Earth pulls us towards it, keeping us firmly planted on the ground, dark matter, too, exerts a gravitational force. But this force is on a much grander scale, affecting entire galaxies and clusters of galaxies. This gravitational effect is what suggests the existence of dark matter. It's a bit like feeling the wind without seeing it. We can't see the wind itself, but we can see the leaves rustling and feel the cool breeze against our skin. So, we have this massive, invisible entity shaping the universe as we know it, quietly influencing the movements and formations of galaxies. It's like a cosmic puppet master pulling the strings from behind the scenes, yet, despite its pervasive presence, it remains unseen, undetected. So if it's everywhere, why can't we see it? Why is dark matter invisible? Stay tuned as we delve deeper into this cosmic mystery, peeling back the layers of the universe, one enigma at a time. What if you were told that a guest has been living in your house unseen and unnoticed? Quite the unsettling thought, isn't it? Now imagine that this guest isn't merely hiding in your home, but is instead a fundamental part of this entire universe, an invisible entity that despite its omnipresence has remained unseen and undetected. This is the enigma of dark matter. Dark matter is the invisible guest in our cosmic home. We can't see it, touch it, or interact with it in any conventional way. It's like a shadowy figure that lurks in the corners of our universe, making its presence known only through its immense gravitational pull. But why is dark matter invisible? The answer lies in its unique properties. Dark matter doesn't interact with light or other forms of electromagnetic radiation. This is quite unlike the matter we're familiar with. Shine a light on a chair, a tree, or even a planet, and it will reflect or absorb that light, making it visible to our eyes. But dark matter, it doesn't care for our humanly visible spectrum. It neither absorbs nor reflects light. It simply lets light pass through it as if it wasn't there at all. This unique characteristic poses significant challenges for scientists. Our current understanding and study of the universe is largely based on our ability to detect and analyze light and other electromagnetic radiation. But when it comes to dark matter, these tools are almost useless. It's like trying to catch a ghost with a butterfly net. So we find ourselves playing a cosmic game of hide and seek, trying to understand and detect something that doesn't want to be found. We are left with a puzzle, trying to piece together the mysteries of an entity that doesn't interact with the world as we know it. But how do we know it's there if we can't see it? That, my friends, is the question that has sparked countless scientific quests, and the answer is as fascinating as the question itself. But we'll delve into that in the next scene. You might not see the wind, but you can see its effects. Can the same be said about dark matter? Dark matter, this elusive guest of our universe, has given us clues that suggest its existence. Let's unravel these together. First off, we have the gravitational lensing effect. Albert Einstein's theory of general relativity tells us that massive objects can bend the path of light. It's like when a pebble is thrown into a pond, creating ripples that distort the surface. Now imagine the pebble as a galaxy, and the ripples are the bending of light around it. When scientists observe this light bending in ways that can't be explained by visible matter alone, it's a strong hint that something else, something invisible, is at play. Enter dark matter. Next up, let's talk about the rotation of galaxies. You see, galaxies rotate at such speeds that the gravity generated by their visible matter should not be able to hold them together. They should be tearing themselves apart, but they don't. Something unseen is providing additional gravity, keeping the stars in their beautiful spiral dance. That unseen something, you guessed it, dark matter. Finally, let's consider the structure formation of the universe. The universe is not a random jumble of galaxies. Instead, it has a vast cosmic web-like structure with galaxies clustered along invisible threads. Simulations show that this structure can only form if there's a lot more gravity than what visible matter provides. Our invisible guest, dark matter, is the prime suspect. So we have clues, tantalizing pieces of a cosmic puzzle. We have the gravitational lensing effect, the rotation of galaxies, and the structure formation of the universe. All these point towards an invisible presence, a mysterious entity that silently shapes our universe. Are we any closer to solving the mystery then? Well, we may not have all the answers just yet, but we're certainly on an intriguing path, don't you think? The story of dark matter is a detective story unlike any other, a cosmic whodunit that we're all part of. Stay tuned, the investigation continues. Like detectives, scientists have their theories and experiments, so what are they on to? Imagine yourself being a part of a grand cosmic investigation, the mystery, dark matter. Scientists have been piecing together clues, developing theories, and conducting experiments in an attempt to solve this enigma. One such theory that has gained traction is the WIMP theory, which stands for Weakly Interacting Massive Particles. This theory proposes that dark matter is composed of unknown subatomic particles that interact weakly with ordinary matter. But theories are just the starting point. To validate them, we need experiments. And in the world of dark matter, these are not your run-of-the-mill laboratory tests. These are large-scale, intricately designed experiments that aim to detect the elusive WIMPs. One such experiment is LUX, or the Large Underground Xenon Experiment. Nestled a mile beneath the Earth in the Black Hills of South Dakota, LUX is designed to detect the faint interactions between WIMPs and ordinary matter. Then there's the Xenon experiment taking place deep under the Gran Sasso Mountain in Italy. This experiment, much like LUX, uses ultra-pure liquid xenon in a bid to detect the ghost-like WIMPs. However, not all scientists are betting on WIMPs. Some are placing their bets on another contender, the axion. According to the axion theory, dark matter could be composed of extremely light particles that barely interact with the universe around them. To test this theory, scientists are using experiments like ADMX, which uses a powerful magnet and a sensitive microwave receiver in an attempt to detect axions. In the grand detective story of the cosmos, these theories and experiments are our magnifying glass, our forensic lab. They are our means to probe the unseen, to understand the unknown. As we inch closer to understanding, the question remains, what if we finally uncover the mystery? Unmasking the invisible guest, what changes? This is the question we're left with as we ponder the implications of understanding dark matter. It's a question that reaches into the very fabric of our reality and teases at the edges of our understanding. If we were to truly understand dark matter, the implications for physics would be profound. It's like suddenly realizing that the majority of the chessboard was invisible to us, and now we're seeing the whole game for the first time. The laws of physics as we know them would need to be rewritten, expanded to encompass this new, unseen majority of the universe. We'd be venturing into uncharted territory, a new frontier of knowledge waiting to be explored. Then there's the impact on cosmology, the study of the cosmos, our universe, and everything in it. Understanding dark matter could give us insight into the birth of the universe, the Big Bang, and the ultimate fate of our cosmos. Could it lead to a new understanding of how galaxies form and evolve? Could it help us answer the question of why the universe is expanding at an accelerating rate? The possibilities are as vast as the universe itself. And let's not forget about our understanding of the universe. Right now, we're like children peering out of a window at night, catching glimpses of distant stars, but not fully understanding the night sky. With a grasp on dark matter, that window could become a door, opening up a new perspective on our place in the cosmos. We'd no longer be children in the dark, we'd be explorers in a universe that's just become a whole lot bigger. So as the cosmic party continues, remember you're part of it even if you can't see all the guests.